boom, chicka, boom, chicka, boom, 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 chicka, boom, 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 chicka, boom, boom. This is section 6.3, conditions for parallelograms. This is Mr. Lane coming at you again from OHS High School. This is for the Geometry iPad Initiative class. Make sure you read the objective, the why. Answer question number 5 in your notes, and let's get rolling on this. You'll notice that most of these theorems are just the converse of the last section, so they're almost the exact same items in them. They're just kind of flip-flopped, the hypothesis and the conclusion. The first one here is if one pair of opposite sides of quadrilateral are parallel and congruent, as the markings show right here in the purple, then the quadrilateral is a parallelogram. So if we have those two things, we know that that quadrilateral will be a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So notice if we have these two sides marked congruent, these two sides marked congruent, that would be a parallelogram. The next one says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this is ways to show that we have a parallelogram. Notice that the markings show opposite angles congruent. Let's move on. The next one is if an angle of a quadrilateral is supplementary of both of its consecutive angles, then the quadrilateral is a parallelogram. Notice if either 1 or 2 here adds up to equal 180, or the 1 or 2 here adds up to equal 180, then it would be a parallelogram. Alright, then the last one here is the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So notice if we got this marking and this marking, this would be a midpoint. That would signify that it is a parallelogram. Let's move on. Alright, so we got a first example here. Looks like we're supposed to show that this is a parallelogram for a equals 3. So I'm probably going to plug in some a values right there. It looks like we're going to let that equal 3. We're going to let that equal 3. So let's see, 10 times 3 would be 30, plus 4 would be 34. Let's see, 3 times 15 is 45. 45 minus 11 would also be 34. So this side and this side would be congruent. Now it says that b equals 9. So right there we're going to let that equal 9. Right here we're going to let that equal 9. So we got 45 plus 6. 45 plus 6 would be 51. And then we've got, 72 minus 21. I believe that's going to be 51 also. So if this side and this side are congruent, we'll put a couple markings right there. Bada boom, bada bang, we got a parallelogram. Let's move on. Show that this is a parallelogram for x equals 10 and y equals 6.5. Well, we're going to plug in the x first. So if we let x equals 10, this would be 150. 150 minus 16 would be 134. Alright, so it looks like we got to plug in a couple of y's. So we're going to plug in 6.5 into the first. So we're going to have 8 times 6.5 equals 52. 52 minus 6 would be 46. Alright, then we'll come right over here to this one, I guess, and we got to multiply 6 times 6.5. By the way, secret word today, insanity, just like the work I do, insanity. Alright, that's going to be 39 plus 7. Boom, we got 46 for this also. So remember, if consecutive angles add up to equal 180, and if I add 46 plus 134, that equals 180. 46 plus 134, that equals 180. So therefore, I have another parallelogram. Alright, regular geometry students would be doing problems 2 and 10 from 402. iPad Initiative students, yours is always on the Lumen Touch website. Determine if each quadrilateral must be a parallelogram. Justify your answer. So let's see. If I add these two, it equals 180. Add these two, it equals 180. So yes, we got consecutive angles supplementary. So this one would be a yes. And I believe it's 6.3-5. Nope, -4. Alright, this one only has one pair of opposite angles congruent, so we know nothing about the other two, so this one's just going to be a no. There's not enough markings on it. Alright, regular geometry students would be doing 4, 12, and 13 from this page. iPad Initiative students uses on the Lumen Touch website. Alright, show that quadrilateral. JKLM is a parallelogram by using the given definition or theorem. It says definition of parallelogram here. Let's go ahead and plot these real quick. I've got -1, -6, 1, 2, 3, 4, 5, and 6 right down here. That is J. Then I've got -4, 1, 2, 3, 4, -1 right here. That is K. And then I've got L at 1, 2, 3, 4, 1, 2, 3, 4, 5. This is L. And then M is at 1, 2, 3, 4, 5, 6, 7. And there is going to be our quadrilateral. And we got to show that this is a parallelogram real quick. So I'm going to go ahead and draw the sides in. And then I think we're just going to show it by showing that opposite sides are parallel by just counting the rise over run. So let's do that real quick. From J to K, I'm going to go up 1, 2, 3, 4, 5, over 1, 2, 3. So that's going to be a rise of 5 over 3, and that is slanting negative, so I'm going to slap a negative right there. And now I'm going to count the same on the opposite side and go up 1, 2, 3, 4, 5. So it's a rise of 5 again. 1, 2, 3. A run of 3, making it a -5/3 on this side. So those two sides would be parallel. We got to show the top and the bottom parallel real quick, so we got to count again. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. So this one's slope would be 6 over 8, which would reduce to 3/4. And then we got to count this last one here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So again, we got a 3/4 slope. So opposite sides would be parallel. Bada boom, bada bang, it's a parallelogram. Alright, we got one more example of those to do, it looks like. So we're going to count 1, 2, 1, 2, 3. This is A. And then we got 1, 2, 3, 4, 5, 6, 1, 2. This is B. And then we've got 1, 2, 3, 4, 5, 0. This is C. And then we got 1, 1 right here. This is D. Now notice that it says that we got to do it by 6, 3, which is that opposite sides are parallel and congruent. Right here we're just going to count. I think we're just going to try these two to do. I got to count 1, 2 over 1. So that's a slope of 2. 1, 2 over 1. That's a slope of 2. So we got the opposite sides are parallel. Now we got to do that they're congruent. So looks like we got to probably plug out distance formula. Distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so we probably want to put a couple of points on here. Actually, we got the AD would be these 2 points right here. So this is going to be my x1, my y1, this will be my x2, and my y2. So let's see. I've got to go a 1 minus a -2, which would give me a 3. 3 squared would be 9. Plus, let's see, I'd have a 1 minus a 3, which would be a -2. -2 squared is going to be a 4. So we're going to have the square root of 13 for this distance right here. So AD would equal 13. Now we got to do the other side, which is BC. So I'm going to relabel here x1, y1, x2, y2. So I'm going to take x2, which is 5, minus 6, which is a -1. Squared would just be a 1. And then I've got, let's see. Oops. Yeah, I did that right. Now I've got 0 minus 2, which would be a 4. 4 squared would actually be, 2 would be 4. let's see, that would actually be the square root of 5. So let's check back over this one real quick. I should have an x2 minus an x1. Actually, that would just be a, sorry, messed up right there. That would just be a 1. 1 squared would be 1. 1 plus 4 would actually give me 5. So both of them would be the square root of 5 for their distance, which would make them congruent. So if they're parallel and congruent, that would be a parallelogram. Alright, there's a little summary for you over the conditions that would prove that it's a parallelogram. And looks like we're going to wrap this up. So this is Mr. Lane signing out from OHS High School. Have a wonderful day.